In this video, we'll take a look at some examples of probability. So refer to your textbook to take a look at these concepts in depth. But the first part of our video, we have just some general information about probability. The definition of what the probability of an event is, basically the number of ways the event can occur divided by the number of possible outcomes. Probabilities are always between and including 0 and 1, where 0 is impossible, 1 is certain. An unusual event has a low probability of happening, and typically this is less than 0.05. So the complement of an event is the probability an event does not happen. So probability of E complement is 1 minus the probability of E. Then we have general addition rule, multiplication rules, some definitions about what mutually exclusive means. Events are disjoint if they have no outcomes in common, or another name for that is mutually exclusive. And independent-dependent. Two events are independent if the occurrence of event E in a probability experiment does not affect the probability of event F. They are dependent if event E affects the probability of event F. So as we go through the examples, we're going to be using these properties. All right, first example is a probability model. A probability model is a table that lists all the outcomes in an experiment or in a situation and all of the associated outcomes. So the table that we have is a table of the percentage of M&Ms, or the probability of selecting a certain color of M&M from a bag of M&Ms. So notice in this probability model, it has all of the possible colors of M&Ms and then all of the probabilities associated. To check and make sure it's a probability model, the sum of all the probabilities has to equal 1, and each probability is between 0 and 1. So if you add these together, you'll get a total of 1.00. So to answer questions that have to do with the probability model, we take a look. What is the probability that a randomly selected candy is yellow or red? So up in the table, we find probability of yellow, and we're going to add to that probability of red. This is the addition rule. So probability of yellow plus probability of red. That is the OR added together. So we're going to take 0.14 and add to it probability of red, which is 0.13. So the probability total is 0.27. Next question. If your bag has 1,000 candies, how many blue M&Ms are expected? Well, if blue M&M has a probability of 0.24 from the table, then if your bag has 1,000 candies, we're going to take 1,000 times 0.24, which is 240. So you would expect about 240 blue M&Ms. Third question is, third question, if you randomly select a candy, what's the probability it is not brown? So this is a complement. The probability of brown is 0.13. So the probability of complement is 1 minus the probability of brown. So that would be 1 minus 0.13, which equals 0.77. So the probability of brown is 0.13, the probability of not brown is 0.77. So the next example that we'll take a look at, and what we're going to focus on in statistics, is more about data that we've collected that is qualitative data, and it's stored in two-way tables. So a two-way table is a table that relates to two items. So in this particular table, we've got male, female, and total in millions. So we've got gender, and then we've got never married, married, widowed, divorced, separated. So then we have marital status. So this table relates marital status to male and female. So we're going to use the table to answer the following questions. So question A, determine the probability that a randomly selected U.S. resident 15 years old or older So that's what the table represents. Are all U.S. residents 15 years old or older? So okay, so determine the probability is male. So we want probability male. So that's going to equal the number of males over the total in the table. So the probability of male is equal to the number of males. So we've got to add together and look at the total. 122.5 divided by the total, which is 251.3. So once you have this fraction, you can divide and express your probability as a decimal. So I'm just going to set these up, and then whatever homework determines whether you should round to 2 places, leave as a fraction, etc., then I'll leave it up to you to express the answer. Part B says determine the probability that a randomly selected U.S. resident 15 years old or older is widowed. So now we're looking at probability of widowed. So that's going to be the number widowed divided by the total. So widowed is a row variable. So widowed, if we add the row across, we get a total of 14.3 divided by the total 251.3. Part C, determine the probability that a randomly selected U.S. resident 15 years old or older is widowed or divorced. So we want probability widowed or divorced. So in this case, that's a addition rule. We're going to take probability of widowed plus probability of divorced, and then subtract out if there's any that are both widowed and divorced. Okay? So both of these are row variables. We have widowed, we have divorced, so there is no overlap. So they're not going to be any that are both at the same time. So these would be called mutually exclusive or independent, that one does not depend on the other, and there aren't any that are in both categories. So probability of widowed would be the number of widowed, 14.3, over the total, 251.3, plus probability of divorced is the number divorced, 25.4, divided by 251.3. Add these together, 0.7, let's see, 25 plus 14, 39.7, divided by 251.3. And again, you'll want to put these in decimal form. I'm just setting them up. All right, part D. Determine the probability that a randomly selected U.S. resident 15 years old or older is male or widowed. So now we have probability of male or widowed. So that would be the probability of male plus the probability of widowed minus the probability of anyone that's male and widowed that satisfies both of those. So this time when we look, we're taking a look at a row variable and a column variable. So the probability of male, we have this column. There are 122.5 males out of 251.3. Then we add to that probability of widowed. Widowed is a row variable. There is overlap. So the probability of widowed is 14.3 over 251.3. Notice that we counted these 3.1 twice. So that's when we say we have to subtract the probability of anyone that satisfies both of those conditions, because we've added them in both the row and the column. So we have to subtract out the 3.1 over 251.3. So if we add our fractions, we get 122.5 plus 14.3 minus 3.1, 133.7 over 251.3. All right, so that's how we use the properties when we're taking a look at probabilities in a two-way table. All right, next item we're going to look at and topic is conditional probability. So the notation, the probability of F given E or F slash E is read the probability of event F given event E. It's the probability that the event F occurs given that E has already occurred. So let's look at an example before we take a look at a table and how it works. So an example, suppose a single die is rolled. So a single die has a sample space. Your possible outcomes for a single die are the numbers 1, 2, 3, 4, 5, and 6. So the probability that the die comes up a 3 is we take a look at the number of 3s. There is 1 out of 6 total. Okay, so now suppose the die is rolled a second time, but we're told the outcome will be an odd number. What is the probability the die comes up 3? So now we're not looking at all possible outcomes. Now we're given that it's an odd number. So the only numbers we're looking at are 1, 3, and 5. Notice we changed the sample space or the possible choices because we had a little bit more information. That's the given. It gives you more information. So now what's the probability we roll a 3? Well, there's 1 3 still, but now we know that our odd number came up. So there are 3 odd numbers, so our probability is 1 out of 3. So the conditional probability affects the total. You're given more information, so it affects the sample space or the total. So the next, we're going to use the same table that we did in the previous example and take a look at how this works when you're given a table. So question A says, same table, this is a two-way with gender, male, female, and marital status. So A, compute the probability that a randomly selected individual has never married, given the individual is male. So find the probability never married given the individual is male. So before we used entire 251.3 as our total. Now we're given male. So it's limiting our sample space. So look at what the given is first. If we're given male, then only thing that we can look at is the column that contains male. So we're still going to find the probability of never married, but we're limited to only the column that says male. So how many males were never married? So never married males, there were 41.6, divided by the total number of males, which is 122.5. Part B, compute the probability that a randomly selected individual is male given the individual is never married. So this switches it around. Probability of male given never married. So we're not going to use, the given now is never married, so we're not going to use the column of males. Instead, we're going to use the row of never married. So for part B, we're looking at this row only. And we still are looking at males, but we want males that have never married. There are 41.6 males that have never married, divided by the total that have never married, 78.5. So when you switch these around, never married given male or male given never married, they are not equal to each other. Both of them limit your sample space. The given is different types of information, so our sample space, our totals are different values, so they're not equal to each other. All right, so there's an example from homework. So take a minute or two and try it out. So let me make this a little smaller so you can see it. So if you want to pause the video and then try the sample, and then we'll come back and take a look at it. All right, so the data in the table represent the number of drivers involved in fatal crashes in a certain region by day of the week and gender. Complete parts A through E below. So the data has male, female, and then days of the week, Sunday through Saturday. So for A, determine the probability that a randomly selected fatal crash involved a male. So we would take male, 25,952, divided by total, 39,911. And then you would put that in the calculator and round to 3 places. Question B, determine the probability a randomly selected fatal crash occurred on a Wednesday. Okay, so Wednesday is what we want. So probability of Wednesday, so the number of crashes that occurred on Wednesday total is 4975 divided by the total 39,911. Okay, part C. Determine the probability that a randomly selected fatal crash occurred on a Wednesday and involved a male. So Wednesday and male. So when you look at the table, we have Wednesday, we have male, female, and total. So if we want Wednesday and male, then we only use the single entry, 3277. Divided by the total, 39,911. Next, D, determine the probability that a randomly selected fatal crash occurred on a Wednesday or involved a male. So Wednesday or male. So probability of Wednesday, we use the row total, which is 4975, plus probability of male, use the column total male, 25,592. Notice we counted Wednesday and male twice. So we counted this 3277 twice. So we're going to subtract out the 3277 and then divide by 39,911. All right, last question. Would it be unusual for a fatality to occur on a Thursday and involve a female driver? So Thursday and female. Here's Thursday. We have the number of males, number of females is 1,874 divided by 39,911. This time we'll go ahead and compute. 1874 divided by 39,911 is about 0.047. So the question says, is that unusual? So unusual, unless it's defined any other way, is typically 0.05 and less. So 0.047 is less than 0.05. So yes, it would be unusual.